A stock trader has access to high volumes of information to help that stock trader make decisions about whether or not to buy an asset. A trader who's considering buying a share of Google stock can find charts, reports, and statistical tools to help with their decision. There are a variety of machine learning products to help a technical investor create models of how a stock price might change in the future. Real estate investors, on the other hand, do not have access to the same data and tooling. Most people who invest in apartment buildings are using a combination of experience, news, and basic reports. Real estate data is very different from stock data. Real estate assets are not fungible. Each one is arguably unique from all others, whereas one share of Google stock is the same as another share, but there are commonalities between real estate assets. Just like collaborative filtering can be applied to find a new movie that is similar to the ones that you've already watched on Netflix, comparable analysis can be used to find an apartment building that's very similar to another apartment building, which recently appreciated in asset value. And this comparable analysis, by finding traits that are similar in apartment building purchase opportunities, is the backbone of Skyline.ai. Skyline.ai is a company that is building tools and machine learning models for real estate investors. Or Hiltch is the CTO at Skyline.ai, and he joins the show to explain how to apply machine learning to real estate investing. He also describes the mostly serverless architecture of the company. This is one of the first companies that we've talked to that is so heavily built on managed services and functions as a service. And so it was really fascinating to hear about their backend because it's markedly different than a lot of the other companies that we've talked to. The fact that they are so heavily built on managed services and, quote, serverless infrastructure. Leap.ai matches you with high-quality career opportunities. You are more than just your skills and a job description and a resume. These things can't fully capture who you are. Leap.ai looks beyond these details to attempt to match you with just the right opportunities. You can see it for yourself at leap.ai/sedaily. Searching for a job is frustrating, and Leap tries to reduce the job search from an endless amount of hours, days, weeks, to as little as 30 seconds, trying to get you matched to a job instantly by signing up based on your interests, your skills, and your passions. Leap works with top companies in the Bay Area, unicorns and baby unicorns. Just to name a few: Zoom, Uber, Pony.ai, Cloudera, Malwarebytes, and Evernote. With Leap, you are guaranteed high response and interview rates. You can save time by getting direct referrals and guaranteed interviews through Leap.ai. Get matched to jobs based on your interests, your skills, and your passions instantly when you sign up. Try it today by going to leap.ai/sedaily. You would also support Software Engineering Daily while looking for a job. Go to leap.ai/sedaily. Thank you to leap.ai. Or Hiltch, you are a co-founder and CTO at Skyline.ai. Welcome to Software Engineering Daily.
Thanks for having me on.
Yeah, it's great to talk to you about this set of challenges that you're tackling. Can you give a brief description of the problem you're trying to solve at Skyline AI?
Certainly. Yeah. So the problem that we're trying to solve is basically mostly around being able to make real estate investments more precisely in the same, scientific manner that we're used to from doing pretty much everything else these days, right? So I could be, selling stuff on Amazon or, trying to get a loan or whatever. And by doing that, these days, almost all of these things would be highly powered by machine learning and other data-driven approaches. And the thing about real estate investments that it's kind of like still remained traditional in the sense that it's very, very much intuition based. And sometimes that intuition works. And in fact, some of what we're trying to build is exactly that intuition, only like mathematically, so to speak. But a lot of that intuition is sometimes based on some cognitive bias that turns out to be wrong. So our main vision is to basically, try to advance this world of real estate investments into, the age of technology, or, to make it somehow more comparable with what we're used to from, the stock market, where robotic trading is currently, responsible for about 70 or 80% of trading.
So real estate investing is a topic I'm somewhat familiar with because my mom has been in real estate for about 10 or 12 years in Austin, over the course of which Austin, Texas has grown. It's expanded a lot. And it's one of those markets there's asymmetric advantage that you can accumulate by experience, essentially. So over the past 10 or 12 years, she's had her ups and downs, but now she has so much knowledge and so many relationships that she can really get a good grasp on the information that's out there. But even so, I feel like this is the kind of set of tools that would be really useful to her, because if she had a dashboard in front of her that said, hey, here's a lot of heuristics or insights, and maybe you could drill down further into this, I feel like that would be really useful. Now, obviously, the ideal would be that you would have so much information that it would be like you're sitting in front of a Bloomberg terminal for real estate, and which is, a Bloomberg terminal, for those who don't know, is, for traders. A trader sitting in New York or in Chicago has this operating system of information in front of them for how to trade stocks or bonds or currencies. And you don't need to be in Turkey to know about currency fluctuations of Turkey. All you need is the Bloomberg terminal in front of you. So where do you think you're at in terms of progress between the sort of tool that gives you some insights that are useful, but you still need to be in the area, you still need to have some domain expertise, versus the Bloomberg terminal?
Right, so that's a great question. So there's no doubt that, real estate experts, brokers, and those guys know their markets inside and out. The good broker or the good experts like your mother has seen, dozens or even hundreds of different assets during the past 10 or 20 years. But, eventually their field of view is still limited by that experience. The AI that we're building, it has like about 50 years of experience, and it has seen all assets in all times. And it's also able to basically extrapolate insights from all sorts of, commonalities that aren't necessarily dependent on the geography. So, for example, you would imagine an asset in Seattle, which is, maybe shares a few things with an asset in New York, just because both of those assets are, relatively close to an Amazon office, and the tenants are roughly the same, and the parks in the area are roughly the same, and so forth. So so definitely, even the best of workers could definitely use something like a tool that powers it, to basically uncover all of those hidden correlations. Regarding where we're actually at the moment, so currently, technology-wise, our focus is on basically being able to predict things like market value of assets. So we're operating in the commercial real estate environment. So that would be multifamily assets and above, so not single-family homes. And in that market, it could be fairly difficult to assess the value of an asset. So our algorithm is basically able to generate a really, really high accuracy prediction for those market values. And we're also about generating future rent predictions. So these are the areas where currently, I would say, we're definitely already providing a lot of value. We like to call that the Iron Man suit for real estate underwriting. So it doesn't act as to completely replace the analyst. It basically just, arms them with superhuman abilities when it comes to, getting to know the asset really, really deeply.
Yeah, so it's kind of like the chess player who has a computer helping them to evaluate the set of moves, the centaur chess model, the augmentative model. Why are you focused on commercial real estate instead of also including the single family occupancy homes as well right now?
So basically, Skyline was born out of a personal lead that we had, myself and my co-founders, where we actually invested ourselves in multifamily assets. And that asset class has actually a lot of advantages when it comes, to things like defensibility, because in a multifamily asset, it's basically a rental property, right? So whenever the economy is down, the occupancies levels are still fairly high. So there are a lot of things that that make this sort of asset really interesting for us, because we kind of like enjoy the fact that it's residential in a sense, right? Because people actually live there. So a lot of features that are really interesting for residents, like schools, the crime rates, walk score, and things like that are relevant to that asset. But on the other hand, it's an asset that is traded by huge companies which have commonalities like holding periods, like certain areas where they like to invest, like certain things that happen to the assets before they try to dispose of it. So it's really an asset class that we figured was perfect for us, to attack as the first go-to market when it comes to developing accurate models.
Are the data sets more available in commercial real estate than residential single-family occupancy?
So it's debatable, because there are data sets around multifamily. So we are actually paying quite a lot of money for data these days. But the truth is that none of the data sources, so there is no real one or even 10 data sets that you could use to get the complete picture when it comes to multifamily, just as there isn't one in single family. The truth is that we actually spend a lot of our work. So we actually, in our R&D group, we basically have two teams. One team is the data engineering team, and these are the guys who are responsible for getting the data and normalizing it, and eventually building this one nice, clean, homogeneous layer that the data science team could then later on connect to generate all of the insights. So it's really a game of being able to periodically download and stream hundreds of different data sources with many dependencies between them in order to basically gain this understanding. So it's not a picnic, but I would assume that it's not, the situation is not really different for single family as well.
What I've heard about building these kinds of machine learning companies is oftentimes you are gated by access to the data, whether you're talking about building a machine learning model for predicting the severity of a stroke, or you're trying to build something around mapping. In all of these cases, it comes down to, can you get the data? Is there even somebody that you can buy the data from? Once you find that person who you can buy the data from, do you have the budget to afford it?
Yeah, so it's a really, really big barrier to entry to this market. That's definitely true. And I think that a part of what we do to mitigate, so this problem exists obviously in real estate as well. In real estate, there are, at least in commercial real estate, there are several so-called commercial real estate analytics companies that you can buy data from, but that data is not always that accurate. So one thing that we do in order to solve this problem is we actually partner with funds, private equities, and other real estate players in a sort of relationship where we provide them with some insights about some of the deals and properties that they're looking at in exchange to getting some of their proprietary data. One such example is an agreement that we have with Greystone, which is one of the largest lenders for multifamily in the States, where we actually enjoy this partnership in a way that definitely helps us get more quality data.
Before we get into the guts of how your company works, I'd like to take a step back and talk a little bit about the core hypothesis of your company, which is that you can use technical analysis for real estate purchases. So there are some people who will, in financial trading, securities trading, stock trading, some people are technical analysts. Some people are fundamental analysts, like Warren Buffett will say you should look at the fundamentals of a specific business. You should look at each business atomically, and rather than looking at how the market is fluctuating and the large collection of signals and trying to derive the wisdom of the crowds from these small technical signals and just accumulating technical wisdom. And then there's a giant amount of people who fall somewhere in between that gradient between fundamental and technical analysis. So I'm sure if there's people who are involved in real estate who are listening to this, they might be thinking, this is a losing game. You can't use these raw stats to figure out how to make a real estate decision. It all depends on, do you know the market? Do you know the people? Do you know the way that the neighborhoods interact with each other? Do you have the macro perspective? Because the historical data is not going to help you. So I'd like to hopefully counter some of the upfront arguments against this kind of platform existing in the world.
Yeah, so I think that eventually what we're building, as I called it a few minutes ago, is kind of like the Iron Man suit for real estate investments. So it's as it is right now, it is not meant to completely replace humans in the process, because the process of a real estate acquisition is actually quite a long one, which includes a lot of manual steps. For example, actually closing the deal, you cannot close a deal in real estate by pushing a button like you can do in the stock market. However, you can definitely use predictions about things like what the asset is actually worth, or what the rent is right now and what it is probably going to be in a year from now. And that is on a sphere of data that you're partly exposed to right now when you're making investments. So most analysts, when they would look into acquiring a multifamily deal or multifamily asset, they would check a few things like the schools around the property and some of the property's comps. Actually, the properties comps is a really good example of how you could actually use this sort of technology to exponentially improve your performance.
Would you say property discount?
So it's called property comps. So when you examine a specific investment or a property, one of the first things that you do is you construct a peer group, which is basically a set of properties which are comparable to your asset. So you want to know that you could buy this asset and then maybe make some value add investment, and then your thesis is that you could charge some premium, following that value add investment. And one of the key things to do in this understanding is to look at comparable assets. So assets which are, for example, traditionally roughly from the same vintage, have the same number of units, are in a close proximity to the asset, and so forth. But usually when the analyst does that, they are fairly limited in their field of view, right? So they would pick, maybe 4 or 5 or go crazy, like 10 assets. And then they would try to get their understanding of, okay, where this asset is standing versus these guys. Obviously, using machine learning, when you can construct a group which is comprised out of thousands of similar assets and not just 4 or 5, your analysis, improves drastically, right? And that's just one example, trying to figure out what is the optimal renovation budget for such a property based on, all sorts of parameters. It's also something which is not trivial to do, without having access to such an abundance of data. And, concerning the actual knowledge of, the locality. So basically, the types of data that we currently have, it could be like really, really local. So I mentioned the actual assigned schools for each property and its grades, the pattern of roads around the property, all sorts of things like that. But it's also macro level data. So for each transaction that we are looking at, for example, in our value prediction algorithm, the machine learning algorithm learns by looking at past transactions. And for each such transactions, it has a really huge features vector, which is also comprised out of macro level data. For example, what was the interest rate back then? What was the 10-year Treasury constant maturity rate back then? What were the LIBOR rates back then? So it's both looking at really high resolution, local properties, but also in really macro level properties.
A couple things there. The idea that you can use your product or a product like it, use machine learning to, for example, predict how much a certain type of renovation is going to cost. That's pretty useful if you're, for example, you're considering buying a commercial property that has an HVAC system that's malfunctioning in this particular way. And you say, I have no idea how to find out. Is there going to be budget creep in this HVAC reinstallation? And what if there's also wiring issues in the building and I need to get those done too? And is that going to overlap with the problems of my HVAC reinstallation? You could imagine being able to predict the prices of those kinds of things would really help you in buying decisions and other kinds of decisions. But the core of what you said there is that comparable analysis has been a big windfall. It's been an insight that has really been useful to you. And in some ways, I think this is nothing new. It's collaborative filtering. This is the same thing that gives you Netflix recommendations based off of people like you or, Amazon recommendations based on people like you or people who also liked this item. This is a well-studied area of machine learning, of computer science. We know it works if you have the right signals, if you have the right data. So what are the signals that you have found to be the highest signal in trying to construct a comparable analysis model?
So that's a great question. So obviously, some of the features are things that I cannot expose because these are some of what makes our secret sauce. But I could definitely mention a couple of those.
Other ones are just latent, right?
Yeah, indeed. Yeah, so a couple of examples is, maybe the more trivial ones would be, all sorts of trends in the property rents. So once you have access, to the history, to like a time series of rent data, of rental performance data, that obviously represents like similarity in some sense. Other ones would be things like more advanced ones would be actually kind of like a digital signature of the property's environment. And I'll explain what I mean by that. So one of the nicest things that we're doing at Skyline is we're actually using machine learning to generate new features for more machine learning models. So we have our supervised learning algorithm, which is responsible for things like the value prediction. But in fact, some of the features that feed into this model are generated by unsupervised learning models. So just as an example, for each and every asset that we're looking at, we're using Google Maps static API to basically take a snapshot of the property's immediate environment, emphasizing things like roads or other points of interest. And then using autoencoders powered by ConvNets, we're able to learn the representation of that environment. So, the ratio and distances between the asset and all sorts of points of interest. For example, things like roads, schools, parks, bodies of water, and things like that. So the use of autoencoders basically allows us to translate that image into a really small vector that eventually is just another feature in our value prediction. So in a sense, it's, the historical rents, whatever compounds the property's environment, a macro level financial figures like, I mentioned the US bonds, so the 10-year Treasury constant maturity rates, which are actually an alternative investment to real estate and things like that.
Citus data can scale your Postgres database horizontally. For many of you, your Postgres database is the heart of your application. You chose Postgres because you trust it. After all, Postgres is battle-tested, trustworthy database software. But are you spending more and more time dealing with scalability issues? Citus distributes your data and your queries across multiple nodes. Are your queries getting slow? Citus can parallelize your SQL queries across multiple nodes, dramatically speeding them up and giving you much lower latency. Are you worried about hitting the limits of single-node Postgres and not being able to grow your app? Or having to spend your time on database infrastructure instead of creating new features for your application? Available as open source, as a database as a service, and as enterprise software, Citus makes it simple to shard Postgres. Go to citusdata.com/sedaily to learn more about how Citus transforms Postgres into a distributed database. That's citusdata.com/sedaily, citusdata.com/sedaily. Get back the time that you're spending on database operations. Companies like Algolia, Prosperworks, and Cisco are all using Citus, so they no longer have to worry about scaling their database. Try it yourself at citusdata.com/sedaily. That's citusdata.com/sedaily. Thank you to Citus Data for being a sponsor of Software Engineering Daily. You mentioned an application there of autoencoders, and I don't think this is a topic that we can completely describe on a podcast, but could you give a few other applications for autoencoders? When are autoencoders generally useful for a machine learning application?
So autoencoders are classically used in noise reduction and anomaly detection. So the basic idea is that using an autoencoder is a mechanism. Its architecture, its underlying architecture could be various types of neural networks, when it comes to using autoencoders over visual data, for example, something like a graph or a map, usually you would train an autoencoder to be able to represent an image using fewer data points. So the autoencoder would take an image and its job would be to restore the exact same image using less data. The result is that the places where the autoencoder isn't able to reconstruct the image as well as it can, so those areas would usually be classified as anomalies. So you would see people using autoencoders in anomaly detections, for example, for monitoring server activity and things like that. Also, like I said, in noise reduction, it's fairly common to use them in noise reduction scenarios when you get a noisy signal and you want to actually figure out what is the signal and what is the noise. Yeah, so those would be two common uses for that.
Interesting. So it's kind of like compression algorithms. The more commonality you have across your data, the more efficient your compression is going to be. And with autoencoders, you can use that to say, well, if we're not able to compress it effectively or encode it effectively, that's in some sense an anomaly by definition. But more generally speaking, in the non-anomaly detection example, you can use it to just reduce the dimensionality of an image, for example, or a set of images, and so your machine learning model can process the data in a collection of images more effectively.
Yes, exactly. So if some of the listeners are familiar with PCA, Principal Component Analysis, which is a method of reducing the dimensionality of a vector. So you could definitely think of an autoencoder as a non-linear PCA, basically being able to apply the same principle, but not using like orthogonal transformation, which only works in when the properties or the features are linearly correlated.
Let's get a feel for the timeline of this business. I was looking at your work history, and you've done a couple other companies in the past, and so this was nothing new to you. What was the process of figuring out what this product was going to be? Did you know it up front, and so you said, okay, let's grab a data set and just start hacking on it and see if there's a there? What was the founding sequence of steps?
Yeah, so it's a great question. I think it's funny that we actually had several other companies in the past prior to Skyline, but Skyline is probably the first company that we established that actually sprung out of a personal need. So prior to Skyline, we had a company around cybersecurity, which was acquired by AVG, the antivirus software company. And then we had a company around video optimization, a company called StreamRail, which was acquired by IronSource in 2006. And then what happened is that we actually started investing in real estate personally. And we kind of like figured out that it's not working too well because, we would have he would have a hard time finding the best deals. And then once we reached an operator, they would provide us with the OM, with the offering memorandum, depicting, all of the deal's characteristics, like the expected yield and things like that. And we had no idea of, figuring out if that data was correct or not, or, and whether or not those predictions about the yield are worth anything. So we started out by, just looking around. We thought, okay, maybe we should, look at what the big boys are doing, the ones who manage the investments for, some of the largest institutions in Israel and in the States. And we got a few introductions to, some of the people who had the global real estate operations for some of the largest private equities in New York City. And we met with them and we saw that, they are not doing a lot of data capabilities are not as good as they could be. Just as an example, so, my little brother, he's a dentist, but he has this hobby of building Irish tin whistles, right? So he builds them from scratch. And it's just a hobby because, in his day-to-day work, he's a dentist.
Irish tin whistles?
Yes. It's a type of flute. It's a pretty nice instrument. Anyways, and he likes to sell them on eBay and Amazon just for the fun, And the type of tooling that he gets, as a merchant on eBay and Amazon to optimize his sales is 1,000,000 times more sophisticated and more data-driven than the type of data tools that, some of the largest private equities in real estate today have. So that was when we realized, okay, so, there is something here that we can probably try to improve, and that was how Skyline AI was born. The next steps were, trying to figure out what can we get from around the web had gone through a really long process of understanding, which of the data providers are more accurate than the others. We've actually built and trained, today we are actually building machine learning models just to tell us which of the data providers is likely to be more accurate, in the property level. So we've gone through quite a big journey, just in setting up the infrastructure for doing this thing.
This is one of those things where you are probably faced with the question, why doesn't this exist? And if it seems like this should have existed, therefore maybe we shouldn't even try it. There's probably very rational reasons that it doesn't exist. Let's go move on to something else. But instead you said, no, there is a reason why this doesn't exist in the market, whether it was the lack of a overlap between somebody that saw this opportunity and somebody that had the machine learning insights to figure it out, or maybe the machine learning tools have gotten easy enough to work with that now you can do this, or maybe the data is more accessible. Do you have any understanding of why this problem had not been successfully tackled before?
Yeah, so I think it's a combination. I think I have my own theory regarding the DNA of the types of players that work in this field. So, there is a growing understanding in the commercial real estate investment world that, AI and machine learning are going to, change the face of the field in the next coming years. And some of these organizations have been able to, recruit a data science team, try to, figure out how can they improve things. But the truth is that the type of challenge that we're facing here is just as much as an engineering challenge as it is an AI challenge, right? So, just being able to, construct this data layer, which is fed constantly from, dozens or hundreds of different data sources with dependencies between them and, concurrency requirements and things like that. So just this part, it's quite a big engineering effort. And you do need an engineering culture. And I would even say startup DNA to be able to manage that. Certainly to converge it with AI disciplines, right? So traditionally, people coming from the AI and data science world are more research oriented, and they're able to do magical things given the correct data. But in this business, it's really about merging both engineering and data science, and this is something that I think has been the big financial institutions have really been struggling with. So that's, I guess, my my R&D manager point of view. But there are a lot of other reasons, right? So it's one of the largest traditional industries in the world today, right? A lot of things are still, based on lack of transparency. So, the bidding process, you can see what a property sold for, but you cannot necessarily tell, what were the bids prior to that. So, yeah, I think these are, some of the reasons for that not to have happened yet.
I love your data engineering hypothesis where you take a big financial institution, they have the data advantage. They have lots of historical data, but it's spread throughout the company, and the people at the top who are asking for that data because they want to make high impact investment decisions based on it, they have to ask a business analyst. The business analyst has to ask a data scientist. The data scientist has to ask a data engineer. And the data engineer has to go find the 50 data sources throughout the company and figure out how to get them together. And, by the time they get all that and they hand it off to the data scientist hands it back to the data analyst hands it back to the VP of, real estate investments. It's been 8 months and the opportunity has passed.
Exactly. Yeah, so I think one of the things I like the most about Skyline is that it's really a weird bunch of people working around the office here. We've somehow been able to merge, those three disciplines into one company that works like a single organism. So we have, the engineering guys on one hand, the AI guys on the other hand, and the real estate people. And they're all working together continuously to improve this. This is something that I think it's really hard to reconstruct certainly in a large financial organization.
Oh yeah. Well, I mean, and not to mention the fact that you can start with modern productivity tools. You can start with Slack and whatever project management tools you use, and the org structure is small enough so that those tools haven't scaled and fractured yet, so you can communicate more effectively. And so it makes a lot of sense. I do want to get a sense of the data engineering pipeline you have. So as far as I understand so far, the input is lots of sources of data from different real estate data systems. And I believe you have all of the commercial real estate or the vast majority of the commercial real estate in the United States across the union of all those data sets. Is that right?
So right now we're actually focused on multifamily assets. So we do cover pretty much all of them. And the way that our data pipeline...
So, and by the way, so that's like apartments. You have like all the apartments and...
Right.
Okay.
So it's apartment complexes, exactly. So the way that we basically have two types of pipelines running on a nightly basis. One is the data pipeline. So that's basically starting out with an in-house infrastructure that we have developed in order to orchestrate the running of the ETLs. So ETLs, an application that extracts, transforms, and loads data. And we have a bunch of these, like around 130. Each such application, it's a standalone application written in Go, in our case, which is responsible for downloading the data from somewhere. It could be from one of our data partners. It could be from using Google Maps API. It could be by downloading PDF documents and then extracting structured data from the handwritten signatures and things like that. So it's really, really varied. So each ETL is a standalone Go application, which is then Dockerized. So we run it inside a Docker container. And we have an orchestrator that basically knows when and how to run each of these Docker containers. So the thing is, once you have a lot of these, so just as an example, I could run the ETL that, fetches the weather data in parallel to running the ETL that fetches the weather data, the crime data, right? Because they're both not related. But I would not want to call the process that generates the new predictions before those two are complete. So if you look at the variety of those ETL applications, eventually you would end up with with something like a graph, like a directed acyclic graph, where each node represents an ETL application, and they have all sorts of dependencies between them, which enable you to run some of them concurrently, or to know that there is no use in running something because its dependency has failed. So we have built an in-house infrastructure to handle that, which is basically running. It's responsible for executing the graph each night. And one cool thing that we did in this process is basically leverage serverless capabilities in order to not be tied into something like a huge machine that would handle all of this load. So in our process, our orchestrator basically kicks off each ETL inside a Docker container, and the runtime for that Docker container is a platform called Hypershell. Hypershell, it's a serverless container platform, kind of like AWS Fargate, which is kind of new. Basically, in 2 words, that means that you could basically tell that platform, look, here is my Docker image, just run it. I don't want to have to worry about, the location or the type of machine or anything like that. And that has scaled pretty well for us, because since each and every ETL is, it has its own different needs, it definitely makes sense to, run them completely separately, on a serverless infrastructure where you don't have to care about things like the memory consumption or, the network and bandwidth and stuff like that.
Is that Hyper.sh? Is it that company?
Yes, it is. Yes, indeed.
Or that's also Zeit, right? Or it's a company under Zeit? Or is that different?
Yeah. So so Hypershell, it's a completely different company, but it is fairly similar to Zeit.
Okay. All right. Cool. And are they using AWS Lambda or Google Cloud Functions or something underneath?
No, they've actually built their own infrastructure. I think they do support, being deployed on AWS, but it's mostly their own stuff.
I've talked to some people that use Airflow for orchestrating these kinds of jobs and the dependency graphs, because like you said, you have this series of ETL pipelines, and some of them may depend on each other. And so that the happens before relationship can be important. You can't just spin up all these jobs willy-nilly. And I believe Airflow is a scheduler out of Airbnb that some people use for this application. Right. Have you looked at that?
Yeah, we have. Yeah, so we've looked into Airflow and Luigi, which is another Python-based DAG execution engine. Back when we started it about almost a year ago. So Airflow was really, really, really not mature at that stage. I think right now it's already under the Apache incubator, so it's probably a lot more production ready than it was almost a year ago when we started looking into that. But back then it didn't quite work well for us. I think another issue is that we really wanted our platform, our ETL platform, to be dynamic in the sense that you would not have to write code in order to add nodes to the graph. And Airflow is imperative in that sense that adding new nodes to the graph means that you, at least back then, it meant that you had to write some code to do that. We really wanted to do that through an API, so we could, play around with it, or get things running through Slack or through, our own user interface and things like that. Yeah, but I did hear that it actually it went a long way since back then, so maybe it's a good time for us to check it out again.
Logi Analytics is an embedded business intelligence tool. It allows you to make dashboards and reports embedded in your applications. Create, deploy, and constantly improve your analytic applications that engage users and drive revenue. You focus on building the best applications for your users while Logi gets you there faster and keeps you competitive. Logi Analytics is used by over 1,800 teams, including Verizon, Cisco, GoDaddy, and JP Morgan Chase. Check it out by going to logianalytics.com/datascience. That's logianalytics.com/datascience. Logi can be used to maintain your brand while keeping a consistent, familiar, and branded user interface so that your users don't feel like they're out of place. It's an embedded analytics tool. You can extend your application with advanced APIs, you can create custom experiences for all your users, and you can deliver a platform that's tailored to meet specific customer needs, and you can do all that with Logi Analytics. logianalytics.com/datascience to find out more, and thank you to Logi Analytics. These ETL jobs run, you get the data, you normalize it all, and then you throw it into what?
Into
database?
A data warehouse.
Data warehouse.
So we're using Google BigQuery as our data warehouse, which has a lot of benefits for our use case. I think just to mention a couple of those. So Google BigQuery, it's kind of like a serverless data warehouse where you don't have to worry about scaling storage or compute or anything like that. Google takes care of that for you. So they used to compare it to AWS Redshift, but now I guess it's more similar to AWS Athena. So Google BigQuery has a lot of advantages for us. It has a really, really strong API. So you could pretty much create a table from anything using a really simple command line interface. So you could tell it, hey, go out and load these bunch of CSVs and use wildcards and everything. And some of them could be gzipped, some of them could be plain out CSVs, and they could be from a bunch of different locations, and it would handle that pretty well. It also has pretty neat automatic schema detection mechanisms. So you could treat it in a sense like a schemaless database. You don't really have to worry about structure changing. And it also supports snapshot queries. So if you want to query tables, to get the data that they held, a few hours ago or things like that, it's built into the syntax. So it's really easy to do. Basically, at the end of the day, it allows us the peace of mind of, having, petabyte scale data all in the same data warehouse without having to worry about, the DevOps part of, babysitting it, indexing it and things like that.
It goes all into BigQuery, and then do you build your applications on BigQuery basically, or do you ever put this data into Mongo or Redis or something?
Yeah. So after it's in BigQuery, it's basically the data warehouse where the main user of this database is our data science team. So what they would do is they would basically source and prepare queries from BigQuery. Then they would code their models. This could be all sorts of models. Some of them, like deep learning models. Some of them are things like gradient boosted trees. So it's quite a large variety of models. And then once they have coded the model and experimented with it, usually using Jupyter Notebook, we would use Google Cloud ML Engine to basically train, evaluate, and tune the model. So Google Cloud ML Engine, it's kind of like it's a cloud platform for, doing everything after the model is already coded. So taking care of, training it efficiently using GPUs or even TPUs, and if you're using TensorFlow, being able to deploy the model and also getting predictions from it. So they could actually, the Google ML engine has the ability to serve an API for the predictions once the model is trained. Then it also provides you with the capability of monitoring, the ongoing predictions. So you can basically compare, things like, training times, accuracy levels, any weird stuff going on with loss functions after data has changed. And then finally, you could also manage your models and versions. So you could, decide which of the models you want to use in production right now. You can A/B test different version of the model and things like that. So that would be the machine learning pipeline. So after the data is already in BigQuery. So that's like one type of user for the platform. The second type of user is the engineering team who is responsible for maintaining our web application. So we also have a Google Maps style web application where you could basically search, for an asset by owner, or by history, by address, by name, or you name it. And then you would basically be able to get tons of insights about the property, like, future predictions about the future rent and things like that within a few seconds. And that application works by querying an AWS Lambda API. And that AWS Lambda API fetches the data either from Redis, if it is indeed cached there, or if there is a cache miss, then it goes out all the way to Google BigQuery.
Wow. Okay, so you've described most of the stack there. We can talk a little bit more about managed services, hopefully. So you mentioned AWS Lambda and Google BigQuery, so it sounds like you're pretty cloud, and Hyper.sh. It sounds like you're pretty cloud agnostic.
Yeah, one of our first priorities is being completely serverless, in the sense that we don't want to have to, spend time on, worrying about uptime and things like that. So yeah, it could be our data warehouse, which is BigQuery. It could be our, API functions, which are served over Lambda, or the ETLs, which currently run on Hyper. We basically just try to pick, the best solution for each part of the problem, regardless of whether it is on Google or Amazon or, or whatever. And this approach is, it's proven itself to be quite efficient in our case.
I love it. I think that's really sophisticated. And I've been talking to a lot of companies that are migrating to Kubernetes, but it sounds like you have built in a way where you don't even really need a Kubernetes cluster.
Yeah, I think that if you nowadays, I think that as long as you could use serverless, so if for example your use case is supported on something like AWS Lambda, then there really isn't any reason not to do it, right? I guess that there are definitely a lot of use cases, for example, like the ETL example, right, where it's not a good fit for something like Lambda because it's long running and it has to manage state and things like that. So for those applications, Kubernetes is definitely a good solution, especially if cost is involved. So, our users at the end of the day are the users of our platform are, only, as I said, we're using the platform to, make better real estate deals, which means that either it is us using the platform to actually, track, source, and acquire the assets, or it is someone from our real estate partners. So in that sense, the scale doesn't come from, the user-facing APIs. So in this regard, cost is not a huge concern for us. It's not that we have to manage, like 1 million requests per second, and then, at which point certainly, managing your own servers on something like Kubernetes makes more sense than using Lambda. Our scale and cost is more on the, data part, like training the models, running the queries. Yeah. So luckily, it's been possible for us to get the best of all worlds when it comes to serverless, and we don't have to to carry the burden of managing something like a Kubernetes cluster.
If the bulk of your processing costs are coming from training machine learning models, does the Google hosted machine learning service, are they always going to be able to schedule and train your models in a way that's more, do they do that in a way that's more cost efficient than if you were trying to do it on your own Kubernetes cluster, for example?
So you could implement, what Google has built with ML Engine on your own, but it's then it comes back to the trade-off you always have between, implementing your own thing. So I guess that on a certain scale, currently at Skyline AI, we are about 20 people, and about 12 of that is engineering. So, I guess that, the larger the company becomes and the more, cost sensitive we will be, in the sense, if you look at Facebook has their own CDN, right? So it never ends. Whenever you have, a big need and you're big enough, you would eventually probably go out and, build your own.
Well, who knows if Facebook would need a CDN if they had started in the age of serverless stuff. Hard to know.
Yeah, I think it is. But I guess, it probably comes back to the trade-off between, how much effort and money you need to put in, to build your own versus just leverage an off-the-shelf solution.
Yeah. Have you been able to avoid downtime and heavy operational issues and heavy debugging issues through this serverless approach?
Yes. So we haven't actually had any downtime since we started the company, since we went to production. And that's still largely due to the fact that it's quite difficult to bring down something like AWS Lambda. We are using a bunch of, logging stuff, and we have some automation around making sure that, production shows what it should show. We definitely get sometimes bugs, the visual aspects of things and things like that. But the infrastructure side, I'm glad to say we've been really fortunate in having quite a perfect uptime thus far.
So there's a lot of stuff we didn't cover, but I guess I do want to take a step back because we're running out of time. This company architecture, the software architecture you have, probably is dramatically different than the previous companies you've had. How does the difference in going heavily on serverless, managed services, AWS Lambda, etc., how does it change the company building side of things, and how does it translate into advantages when you compare the company building exercise today to your previous companies?
Yeah, so Skyline AI is very, very different indeed. I think it's mostly different in the sense that, in a couple of ways. First of all, we really have a mutually respectful size of data science team versus an engineering team. So we actually have more data scientists than engineers at the company, which is also a first for us. And that actually creates a lot of interesting challenges, in basically being able to maintain the kind of like the agile mentality, when you have to deal with a lot of people doing research. So that's one, I think, really interesting challenge that we've had the chance to cope with here, which is fairly different from the previous companies. We also have the fact that, there's a really large business side that is really, really different, from our world as tech guys. And merging that discipline into the company is also something that is, quite refreshing and interesting for us. There are actually a lot of similarities because, eventually we did it in cyber and then we did it in video, but both Visionize and StreamRail were around, at the end of the day, using data to optimize stuff. And while we haven't actually had the luxury of working with completely serverless infrastructures in the past, we have gotten a taste of them, and it was quite clear to us that, whenever these things becomes a reality, then we will be the first to adopt it. So yeah, I think it definitely helped us, scale the technology business because, we don't have to, these days, even we could take a data scientist fresh out of university, doesn't know nothing about DevOps, and they could pretty easily integrate their code into our workflow, which is kind of a complex architecture when you think about it. So it's the same. If I would guess that if we would want to do that, before the way there were the days of, Cloud ML and BigQuery and Lambda, then we would probably have to have, ops guys and DevOps people. Yeah, so it definitely helped us, grow really, really quickly when it comes to, launching the product to production.
Well, I think the hangover from proprietary, like the 90s, proprietary databases, proprietary operating systems, people getting locked into those things, the hangover has been really severe. And so people have been really resistant to jumping on managed services and going all in on them, at least some people. That's just my sample from talking to people. But, I think as for productivity, I'm like, if you're a random hacker in a bedroom, build on Heroku, build on Firebase. If you're starting a new company, build on as much managed services as you can, unless you're on a really low margin kind of business and costs are really that important.
Yeah, I totally agree. I think that, whatever can be done like serverless has to be serverless. Like there is no really justification in doing it in any other way if it is available in a serverless way and if it's a good fit.
So the company's doing fantastic, and you've already got all these commercial properties in the United States. What are the challenges that you're encountering? What are the biggest challenges, and what's in the future for Skyline AI?
So thus far, we've been focused on executing deals on a deal-by-deal basis, which meant that whenever we sourced and underwritten a deal that we liked, we went out to our investor base, which is mostly around like family offices or high net worth individuals globally.
Right. So I'm sorry, I didn't even allow you to explain really the business model. So you surface deals and then you bring them to people, and then people have a chance to invest in the real estate opportunities that you discover?
Right. So basically our model is kind of similar to what is sometimes referred to as private equity. So on one end of the equation, you have capital, and that capital can come from institutions like pension funds or insurance companies, or it could come from family offices, which are companies that manage capital for some rich families. Or it could come from what's referred to as high net worth individuals. So people with enough capital to be able to afford investments in an expensive asset class, right? Like multifamily, where the minimum check sizes could be several millions of dollars. So that's like one end of the equation. And then on the other end of the equation, there are the operators. So these are the guys or the companies that are really doing the hands-on real estate part. So they would be the ones who are actually physically acquiring the property, taking care of managing it, applying the renovation part, and so forth. And in the middle, there are the private equities. So companies like Blackstone, for example, it's one of the most well-known private equities for real estate. And the area where we operate is there. It's in the private equity slot. The difference is that we're doing everything, enhanced by technology. So it could be in the sourcing of the deals, or figure out a certain area that we want to focus on. It could be the underwriting of the deal. So once we already have a deal on the table, we would use our AI in order to make sense of it. But eventually, the business model is roughly the same. We go out and we raise money whenever we think we can make a good investment. So thus far, we've done that on a deal-by-deal basis, meaning that once we had a deal that we thought, okay, we're going to go after this one, we would go out and raise the money. But right now, we are working on changing this a little bit into more like something like a fund structure, where we'd basically partner with a large operator in the States, and together we would be raising a large fund to allow us to deploy more efficiently and more quickly. So that's one of our main goals for the next couple of months. We're already doing pretty good there. And we're already also working, from a technology perspective, we're working on basically expanding to additional asset classes. So we started off with multifamily, but we also have office, logistics, industrial, and a lot of more asset classes coming up. Yeah, so a lot to do.
Very cool. Well, Or, it's been really great talking to you. I appreciate you coming on the show and making time to tell me about Skyline AI.
Sure, thanks for having me.
Cloud computing can get expensive. If you're spending too much money on your cloud infrastructure, check out Doit International. Doit International helps startups optimize the costs of their workloads across Google Cloud and AWS, so that the startups can spend more time building their new software and less time reducing their cost. Doit International helps clients optimize their costs. And if your cloud bill is over $10,000 per month, you can get a free cost optimization assessment by going to doit-intl.com/sedaily. That's doit-intl.com/sedaily. This assessment will show you how you can save money on your cloud. And Doit International is offering it to our listeners for free. They normally charge $5,000 for this assessment, but Doit International is offering it free to listeners of the show with more than $10,000 in monthly spend. And if you don't know whether or not you're spending $10,000, if your company is that big, there's a good chance you're spending $10,000. So maybe go ask somebody else in the finance department. Doit International is a company that's made up of experts in cloud engineering and optimization. They can help you run your infrastructure more efficiently by helping you use commitments, spot instances, right sizing, and unique purchasing techniques. This to me sounds extremely domain specific, so it makes sense to me from that perspective to hire a team of people who can help you figure out how to implement these techniques. Doit International can help you write more efficient code. They can help you build more efficient infrastructure. They also have their own custom software that they've written, which is a complete cost optimization platform for Google Cloud, and that's available at reoptimize.io as a free service if you want to check out what Doit International is capable of building. Doit International are experts in cloud cost optimization, and if you're spending more than $10,000, you can get a free assessment by going to doit-intl.com/sedaily and see how much money you can save on your cloud deployment.
Wow!